What happens when you burn the alkanes? Roll that graphic. So, combustion reactions, what are they? Essentially, all hydrocarbons can be used as a fuel. Well, if they're flammable, so the smaller ones definitely can. Octane all the way up to methane, they can be used as fuels because they're volatile. That means they can be made into a gas pretty easily. They can be reacted with oxygen, and as they burn, they produce a lot of energy. So let's have a look at a general word equation for any fuel. And that would be the fuel plus oxygen will give you carbon dioxide and water. This is a complete combustion reaction. There is such a thing as incomplete combustion. That means there's not enough oxygen. Doesn't mean there isn't any, it just means there's not enough. So let's give an example of methane burning completely. So we've got methane. You're reacting it with oxygen, and you get carbon dioxide and you get water. Dead easy. Let's go to the chemical formulae. CH4 plus O2, CO2 plus H2O. Now, if we try and balance this, it makes it really easy. So this could be in a paper 1 assessment. So you've got 1 carbon, 4 hydrogens, 2 hydrogens. 2 times 2 is 4. Now I've got 2 oxygens, that's 4 oxygens and just 2 here. Voila. Now if I get incomplete combustion, there's not enough oxygen to make carbon dioxide, I might end up making the very dangerous and the very toxic carbon monoxide. Let's have a look at that reaction. So we've got methane, we've got oxygen, we make CO, and we make a bit of water as well. Now, we can still balance this equation. It's going to take a bit of faff in, and we won't be using integers here and here. So let's roll this one out. 1 carbon, 4 hydrogens, 4 hydrogens. 2 oxygens, 1, 2, 3 oxygens. If I put a 3 there, it's 3 times 2 is 6. If I put a 1 there, it becomes 1 times 2, which is still 2. What I can do is I can put a 0.5 or a 1.5. That simply means there's 1.5 times 2, which makes 3. 1, 2, 3. Now, sometimes I might make, or I won't make, but sometimes the combustion reaction might make soot or carbon on its own. If we have a look at this, we end up with C plus H2O. This soot here, this carbon, this charcoal, that's responsible for global dimming. This is responsible for people's deaths. This is linked to climate change because it's a greenhouse gas. Let's have a look at this. CH4 plus O2. Now, I'm still going to need the 2 there. 2 times 2 is 4. There's my 4. 2 times 1 is 2. That's already balanced. I could end up with a combination of the 2 as well. Do keep an eye out for those, but there's nothing there that you can't do. Just remember to relate the fuel plus oxygen gives carbon dioxide and water. Now, this reaction is really useful for any hydrocarbon, but also anything that was alive that is being burned as a fuel. I'm talking about the hydrocarbons and crude oil. Word equations, chemical equations, balance the chemical equations. Now looking at incomplete combustion. Not enough oxygen to form carbon dioxide and water vapour. That's it. Till next time, stay cool. Bye bye.